Energy and environment, sun as source of energy. The sun is a primary source of energy for Earth, providing light and heat through the process of nuclear fusion. In the sun's core, hydrogen atoms fuse to form helium, releasing enormous amounts of energy in the form of solar radiation. Solar radiation and its spectral characteristics. Solar radiation is the energy emitted by the sun, which reaches Earth as electromagnetic waves. The solar spectrum includes ultraviolet UV radiation wavelengths from 100 to 400 nanometers, divided into UVA 320 to 400 nanometers, UVB 280 to 320 nanometers, and UVC 100 to 280 nanometers. Visible light, wavelengths from 400 to 700 nanometers. This range is what the human eye can perceive as different colors. Infrared IR radiation, wavelengths from 700 nanometers to 1 millimeter. This range is felt as heat. Fossil fuels are natural energy sources formed from the remains of ancient plants and animals, subjected to heat and pressure over millions of years. They are classified into three main types: coal, petroleum, crude oil, and natural gas. Let's dive into the classification, composition, physico-chemical characteristics, and energy content of these fossil fuels. First, coal. Classification: peat, lignite, sub-bituminous, bituminous, anthracite. Composition: primarily carbon, with varying amounts of hydrogen, sulfur, oxygen, and nitrogen. Characteristics: higher rank coals have higher carbon content and energy density. Energy content: measured in terms of calorific value, typically ranging from 15 to 30 megajoules per kilogram. Next, petroleum, also known as crude oil. Classification: light, intermediate, and heavy, based on API gravity. Composition: a complex mixture of hydrocarbons including paraffins, naphthenes, and aromatics, along with impurities such as sulfur, nitrogen, and metals. Characteristics: liquid at room temperature with variable viscosity and density. Energy content, approximately 42 to 45 megajoules per kilogram. And finally, natural gas, classification: conventional and unconventional, which includes tight gas, shale gas, and coal bed methane. Composition: primarily methane, with small amounts of ethane, propane, butane, and impurities like carbon dioxide, nitrogen, and hydrogen sulfide. Characteristics: gaseous at room temperature, lighter than air, and odorless. Energy content: about 35 to 40 megajoules per cubic meter. Now let's talk about unconventional fossil fuels. These include shale oil, which is liquid hydrocarbons extracted from shale rock formations through hydraulic fracturing or fracking. Coal bed methane, or CBM, which is methane gas extracted from coal seams, and gas hydrates, which are methane trapped within a crystalline structure of water ice found in ocean sediments and permafrost regions. Moving on to an important concept in energy management: gross calorific value and net calorific value. Gross calorific value, or GCV, is the total amount of heat released when a fuel is burned completely and the products of combustion are cooled to the original pre-combustion temperature. It includes the latent heat of vaporization of water. On the other hand, net calorific value, or NCV, is the amount of heat produced when a fuel is burned completely and the products of combustion are not cooled to the original temperature, thus excluding the latent heat of vaporization of water. NCV is always lower than GCV. Understanding these concepts is crucial for energy management and environmental protection, as they help in evaluating the efficiency and environmental impact of various energy sources.